So here in the previous stage, this was my pivot entering variable. This was my departing variable. This was my pivot column. That was my pivot row. And the intersection of these two blocks is called the pivot number. So 1 is the pivot number.
Hello. Hello.
Yes.
Hi, sir. I'm Souladeep.
Yes. Tell me.
Actually, sir, all are writing in the chat box regarding the attendance. Will I also write?
Yes. Yes. Also, you write.
Okay.
So
Okay.
this is the pivot number. 1 is the pivot number. And now I am going to construct the simplex table 2. So simplex table 2 construction is, you just carefully observe what I need to do over here. And I hope that this time we should get the optimal solution. If we are lucky enough, then we'll get our optimal solution. But if we are unlucky, then I don't know what is going to happen. Just let's hope for the best. Unless the condition is satisfied that all the elements of Zj minus Cj row are non-negative, we cannot stop. So that is the conditions. Very hectic. I mean, you can understand right now that how hectic this particular methodology and why most of the time people are not comfortable with this. But I'm trying my level best to make you understand. I'm moving very slowly, and I'm taking some time so that you can grab all the important ingredients from this particular method. So now
sir,
first, yes.
Hello.
Yes,
sir,
yes.
বলছি ওইটা একটু বলবেন Zj minus Cj টা কি করে হলো?
Zj minus Cj means you are subtracting Cj from Zj. Here you are subtracting this number from that number, this number from that number, this number from that number. Okay. Okay. So now see, your entering variable is x2. Remember, your entering variable is x2, and x2 is going to take the position of s1. So in place of s1, in the new simplex table, we are going to write x2. So s1 will be replaced by x2. s2 will not change because it is not actually creating any trouble. So s2 is, we will keep s2 as it is, no problem with that. And what are the coefficients of x1, x2, s1 and s2? They are same, 2, 3, 0, 0. Coefficients are not changing at all. But now here in this particular simplex table 1, the variables, the basic variables were s1 and s2, so the coefficients were 0, 0. But now the basic variable column has changed. It is x2 and s2. So obviously this CB column will change. So the coefficient of x2 in the objective function, is 3. So we'll put here 3. The coefficient of coefficient of s2 in the objective function is 0. So that will be 0. Okay. Now this line, you write this line. And remember, this position, that means 1, 2, 3. 1, 2, 3. This position was the initial pivot number position. This position was initial pivot number position. Here in this position, pivot number appeared. Just look at this. 1, 2, 3, 1, 2, 3. So I am going to write this sentence to construct. So how's the CB is 3? Because x2 value, x2's contribution, just look at the coefficient of x2 from the top. It is 3. And since x2 has taken its place, so we have this CB is actually are the coefficients of the basic variables. So what is the coefficient of x2? It is 3. And x2 has now become the basic variable. So its coefficient is 3. So I have marked it pink. So this arrow and that tree that you see, that they are of same color. They are correlated to one another. This is yellow marked. This is yellow marked. Try to correlate. And I'm trying to show by these colors. I'm trying to show you the connection. So to construct the simplex table 2, we need to first write all the elements of the pivot row so that pivot number comes out to be 1. Comes out to be 1. This particular statement is very confusing, I know, very, very well. Those who are comfortable with matrix, they will find it easier to identify. It is saying that you want to write the now what do we need to do right now? We need to write these numbers as it is. But first of all, you have to construct the pivot row. What is which one? This is my row 1 and this is my row 2. Which one was my pivot row? My row 1 was my pivot row. So I am going to write row 1, the elements of row 1 first in the new matrix, a new table, in such a manner so that in this position 1 comes. Suppose this pivot number is not 1. This pivot number is not 1. This pivot number is 2. Don't write anything. Suppose this pivot number is 2. I need to write the pivot row in such a manner so that in place of 2, 1 comes. So what we need to do, we need to divide the entire row by 2. So in this case, we will be getting half, 1, half, 0. We need to bring 1 in this position because it was the pivot number position. But fortunately, we don't have to do anything like this over here because it is already 1. So therefore, we'll just copy this pivot row over here. Because of this problem, that means you can think of it in this manner. We are dividing this pivot row by 1 and we are writing the elements. We are putting a star over here to make you identify that this was the position of the pivot number in the previous stage, in the simplex table 1.
Sir, I had a question. Sir, can you repeat what you have said last minute?
Okay, I am saying that suppose I in a particular simplex table, my numbers are like this: 2, 1, 3, 4, 5. And this is my pivot row. Suppose this is my pivot row. In the next simplex table, that means this is my old simplex table. Suppose this is my old simplex table. I'm assuming, in the new simplex table, I have to write this particular row. First of all, this variable S1 will be replaced by a new variable, say X1. And I have to write this row in such a manner, these elements in such a manner, so that in the pivot number position, that means suppose this is my pivot number. This position is my pivot number position. In pivot number position, 1 comes. But here the pivot number is 3. So to write the elements of this row, we need to divide the row by 3 itself, so that 3 by 3 becomes 1. So we'll write 2 by 3, 3 by 3, that is 1, 4 by 3, and 5 by 3. We need to make this position as 1. In this type of situations, this type of techniques can be applied in case of a matrix. So table is nothing but a kind of matrix, because table is also a kind of arrangement of rows and columns. So this operation can be done. But here in this particular position, your in the simplex table 1, your pivot number was originally the pivot number was 1 itself. So we don't have to do anything else to make it 1. It is already 1. So we can just copy it. We are just copying this particular block into the new simplex table. So this is my this is my old row 1, and this has now
Sir,
become Bolo?
Sir, then S2 will be 0, right? In simplex table 2.
Yeah, sorry.
One.
Yes. Oh, this is my mistake. This should be 0. Thank you so much. Very good. New row 1. This is my new, that was my old row 1, and this is my new row 1. I am also prone to mistakes. So I'm very happy that you have identified this silly mistake that I have done. Now I am going to construct this new row 2. New row 2. Can I go to the next page? I have
Yes,
to.
sir.
Yes.
Yes, sir. Yes, sir.
To construct the next row, apply matrix row operation, matrix row operations in such a way so that below the pivot number 1 in the new row 1, 0 appears. 0 appears. Probably we have heard about the Gaussian elimination method in solving a system of equation. Actually, I am applying a kind of Gaussian elimination method over here. But if you do not know if you have not heard of the name, don't have to worry, because I am not mentioning the name at all. Just follow my rules, and this rule is going to be followed for each and every problem related to simplex algorithm. Just do not try to read simplex algorithm from any other book. Read my note, and just you'll be able to do each and every problem. If you look at the books, then you will become confused. So to construct the next row, apply matrix row operations in such a way so that below the pivot number in the new row 1, because the pivot number is appearing in the new row 1, 0 appears. Let's get back to the previous page. I want to bring 0 in this position. I want to bring 0 in this position, because this is the pivot number in the new row 1. This is my old row 2. So what matrix operation that I can do over here is the following. The following matrix operation I can perform in this particular case. If I subtract from old row 2, the new row 1 elements, from the elements of old row 2, if I subtract new row 1, I will get new row 2. And what is going to happen? Just look at this. This is my old row 2. This is my new row 1. I am going to subtract new row 1 elements from old row 2 elements. So just stay with me. 4 minus 1 will give you 3. 3 minus 1 will give you 2. 1 minus 1 will give you 0. 0 minus 1 will give you -1. 1 minus 0 will give you 1. What was our objective? To bring 0 below the pivot number. We have obtained 0 below the pivot number by this operation. I am writing the operation here once again. Old row 2 minus new row 1 will become new row 2. Now all the elements of this particular table has been constructed. Now we need to calculate Zj minus Zj and Zj minus Cj, and let's hope for the best. So the calculation of Zj minus Cj is as before. For the calculation of Zj, now you see my CBT is actually what CBT is. It is the transpose of this matrix. That is the row 30. And let me remind you that Zj is nothing but the product of CBT with Xj. So all the elements will be multiplied by this row 30 now. All the elements. Previously it was getting multiplied by 0, 0. Now it is going to get multiplied by 30 because the matrix is now changed. It is the matrix. So 3 into 1 plus 0 into 2, that is 3. I'm not calculating this one because below this I have written Zj minus Cj. Here also, it's not needed here. 3 into 1 minus 0 into 2, that is 3. Sorry, 3 into 1 plus 0 into 2, that is 3. 3 into 1 plus 0 into 0, that is 3. 3 into 1 plus 0 into minus 1, that is 3. And 3 into 0 plus 0 into 1, that is 0. And Zj minus Cj means this minus this, that is 1. This minus this, that is 0. This minus this, that is 3. And this minus that, that is 0. And we are fortunate enough to get all the elements of this table to be non-negative. All the elements are greater than or equal to 0. Now, in simplex table 2,
here how Jj is calculated.
See the formula. Zj is, if I talk about the column x1, Zj will be CBT into x1 column. CBT is your matrix 30, and x1 column is having this value 1, 2, 1, 2. So if I multiply the two matrices, we will get 3 into 1 plus 0 into 2, that is 3, and likewise, and so on. And so on. Just see. Try to copy this, or if you have taken the screenshot, I'm going to go to the next page and I'm going to write my conclusion. Just tell me that you are ready. Done. Okay. I know you. I know that you are quite tired of this particular method. So let's conclude. Since
Sir, can you show the previous page?
yes, I am also tired.
Thank you, sir.
Yes. since all the elements of Zj minus Cj row in the new simplex table, that is simplex table 2 is, are either 0 or positive, So the simplex table 2 gives us optimal solution. And what is the optimal solution? Optimal solution means we have got the value of our desired value of x1, we have got our desired value of x2, we have got our desired value of s1, we have got our desired value of s2. Now you see, in this column, in the basic variable column, just look at this column. x2 has got value 1 because x2 is present. This is my solution column. This column is my solution column. This rectangular column is my solution column. So x2 is 1. So I'm writing here x2 is 1. In this column, s2 is 3. So I'm writing here s2 is 3. But in this column, since this is my solution column, here x1 and s1 are not present. They are not present. So their values are 0 and 0. And therefore, the maximized value of z is, what is the objective function? Objective function was z prime 2 into x1 plus 3 into x2 plus 0 into s1 plus 0 into s2. Put the values 2 into 0 plus 3 into 1 plus 0 into 0 plus 0 into 3. And the answer is 3. The maximum value of the objective function is 3. And our original objective function was z. Simplex method is so designed so that the maximum value for z prime will be same as the maximum value of z, and therefore the maximum value of z will also be 3. That is your answer. So we have got our x1 is 0 and x2 is 1. I'll come back to this page. Can I go to the next page?
Yes, sir.
Yes, sir.
Now, just to get you a glimpse of what is happening graphically, since you are comfortable with this graphical method, so just since this particular problem was a 2 variable problem, so my original problem was 2x1 plus 3x2 max of z subject to x1 plus x2 less than or equal to 1, 3x1 plus x2 less than or equal to 4, x1 comma x2 greater than or equal to 0. How do we solve it graphically? The line 1 here is x1 plus x2 equal to 1. Line 2 here is 3x1 by 4 plus x2 by 4 is equal to 1. That is, I'm not explaining because this has been explained in the previous class. So I'm going to draw these two lines. First of all, first of all, I'm going to mark the points. So, what are the, I mean, put here 1, 2, 3, 4 in the x2 axis, and in the x1 axis we are going to put 1, 2, 3. What are the lines? The lines are, you see, the intercept for the first one is 1 and 1. So we are joining these two, 1 and 1. Intercept in the second one is 4/3 and 4. So 4/3 means 1.3 somewhere here. I'm joining this with 4. So these are the two lines. And the common feasible region obtained is the following. The common feasible region that I'm going to mark for you. The first line, for the first line, the region is this one. For the second one, the region is the following. What is the common region? Common region is this part where,
How
yes,
the common feasible, how it is determined, the common feasible.
go to my previous class video, previous class lecture, go through it and you will understand. That has been explained. So this is my common region where the marked portion of yellow marked portion and the green marked portion are coinciding with one another. 3 corner points are coming out over here. One corner point is the origin. Another corner point is this one, whose coordinate is 1, 0. Another corner point is this one, whose coordinate is 0, 1. So there are 3 corner points actually, O, A, B. So we are going to put these corner points in the objective function. We are going to find the value of Z for these corner point coordinates. And we see that it is 2 in, for the first one, it is 2 into 0 plus 3 into 0, which is 0. For the second one, it is 2 into 1 plus 3 into 0, that is 2. For the third one, it is 2 into 0 plus 3 into 1, that is 3. And since it is a maximization type of problem, so therefore the maximum value is Z equal to 3, which occurs for x1 equal to 0 and x2 equal to 1. Since it was a 2-variable problem, so we could solve them graphically, and this was helpful because my solution, the solution that I have obtained.
Can you bring the diagram page?
Yeah, I'm going to bring the diagram page. The solution that I have obtained over here is matching with the solution that was obtained with the help of the simplex method. The same solution that we have obtained. Yes.
So from where the 4 is coming, that how we can determine that the line will go from 1 to 4 in the diagram.
Have you seen my earlier videos? Have you seen? Tell me first of all.
No.
See it. I have sent you the link. You will understand that how have I drawn the straight lines. Everything is explained over there.
Sir, which method do we follow? It is mentioned by the question, or
if it is if it is a 2-variable problem and nothing is mentioned and the mark is 5, then you have to do it by graphical method. If it is a 2-variable problem but the mark is 7, then you have to do it by, okay, you can do it by graphical method. If it is a 2-variable problem, the mark is 10, that means the examiner wants you to solve it by simplex method. If it is a 3-variable problem, then you have to always apply a simplex method, be its mark as 5 7, 10, whatever it is. I mean, maybe the methodology described in the earlier problem is not worth 10, it is more than that. But there are some, if I'm talking about the offline examination, indeed, if I'm talking about the offline examination, then the methodology is requires much more marks than 10, because the previous problem ended with only 2 simplex table. It may not be always so. So it requires much more marks. So therefore, you have to be, you will become a disheartened, as some kind of disheartened by looking at the marks, but the bulk of the calculation present in the problem, they will mismatch always. But if it is mentioned that apply simplex method to solve the following linear programming problem, that is beyond question. You are sure what method you need to apply over there. But if it is not mentioned, then you have to be very careful about the marks. You have to justify, you have to decide by your own that what methodology you are comfortable with. Obviously, if I am at your position, then I will look at the marks and I look at the number of variable and equations. If the mark is 7, up to 7, I am saying, up to 7, 5 or 7, and the nothing is mentioned, I will definitely apply graphical methodology for if it's a 2 variable problem. But if it is 2 variable problem and mark is 10, obviously examiner, a 2 variable problem cannot have marks more than 7. So obviously examiner wants me to solve it by simplex, but somehow he missed the point. He's not mentioning it. And if it is a 3 variable problem, then it is beyond question. If it is something is explained specifically, then it is beyond question. And it is, if it is an online examination, then in that case, I will say that questions can be asked, MCQ type of questions can be asked from the methodology itself. I can ask many more questions from the simplex procedure itself that has been described in the video. So this is the thing. Now, if I'm going to ask you something, first of all.